Okay, I'm going to work out the problems I left you. So I'm going to start with page 274, number 1. So it says a particle starts at x equals 0 and moves along the x-axis with a velocity v of t equals 5 for time t greater than 0. Where's the particle at t equals 4? So I want to know how far did the particle go from the start to 4. And so I'm looking for distance, which would be position. So remember, your hierarchy is position, velocity, acceleration. So I need to move up, which means I need to integrate, which at this point means find the area under the curve. So my graph, if I wanted to graph it, would look like this. V of t equals 5. So it's a horizontal line at 5. And if I want to know the area from 0 to 4, I'm doing basically a rectangle. So it'd be 4 times 5. This is what we did the very first day. So it would be 20 units. They didn't give you a unit. So that's just kind of a flashback to what we did at the very start. Okay. So number 2, same type of deal. It gives you a equation. And it wants to know how far did the particle go from 0 to 4. So if you were to graph this, you'll see you started at 1 and you went up to over 1. So you're going to get something like this. Okay, until you get way out here at 4. It's actually going to be a trapezoid if we take that area, right? And we discussed yesterday that the area of a trapezoid is 1/2 the sum of the bases times its height. Well, that height's going to be 4. This first base is going to be a 1. And for the second base, if I put 4 into that, I get 9. Sorry. So let's see, it's at 20. So it'd be 20 units. So the next one gives you a velocity, and it's a little more complicated, but probably more what you're comfortable with. And asks where's the particle at 4, so I want you to go from 0 to 4. And it says approximate the area under the curve using 4 rectangles and determine by the midpoints of the intervals. So 4 rectangles would mean n equals 4. So if I'm finding delta x, I would do 4 minus 0 over 4, which is 1. Which means I'm going to go from 0 to 4 with steps of 1. But it tells me to use the midpoint, which means I'm actually going to use 0.5, 1.5, 2.5, and 3.5. So my delta x is 1 times 0.5 squared plus 1 times 1.5 squared plus 1 plus 1 times 2.5 squared plus 1 plus 1 times 3.5 squared plus 1, which gives me 25. So it would have moved 25 units. And this one, because we use an approximation, we would have said it would have moved approximately 25 units. The other two we did not estimate. We actually found the area, so it's exactly 20 units. So that's a little bit nitpicky, but it's something just good to think about. So number 4, kind of the same deal. So it's asking you to use this equation to go from 0 to 5 and use 5 rectangles determined by the midpoint. So really basically the same thing. 5 rectangles, so delta x 5 minus 0 over 5, that'll give me a width of 1. So I go from 0 to 5, so 1, 2, 3, 4. I'm using the midpoints, so 0.5, 1.5, 2.5, 3.5, and 4.5. So my width is 1, and then it's 0.5 squared plus 1 plus 1.5 squared plus 1 plus 1, 2.5 squared plus 1 plus 1, 3.5 squared plus 1 plus 1, 4.5 squared, squared plus 1. So if you pay attention, this is actually the previous problem with just an extra piece tacked onto the end. Gives me 46.25, or you can type it all in again, either way. So the particle moved approximately 46.25 units. Okay, number 5. Ask you to sketch the region. So you can do that. So it would look something like this. It would go from 0 to 2. And you're finding the area between it and the x-axis on the interval from 0 to 2, so you're finding that. And so that would be A. B would be to partition it into 4 rectangles and use those to approximate. Okay, so I'm going to go from 0 to 2, 4 rectangles, so my delta x is going to be 1/2. So I'm going to use 1/2, 1, and 1.5 for 3/2. And I'm going to use, what is this, LRAM? So I'm going to use the left pieces, the left floor. So my 1/2, my equation was 2x x minus x squared. So it'll be 2 times 0 minus 0 squared plus 1/2. 2 times 1/2 minus 1/2 squared plus 1/2. 2 times 1 minus 1 squared plus 1/2. 2 times 3/2 minus 3/2 squared. So I get that to equal 1.25. So the area is approximately 1.25. Number 6 asked me to repeat that for RRAM and MRAM. So if I did RRAM, My number line again looked like 0, 1/2, 1, 3/2, and 2. So RAM would be 1, 2, 3, 4. So my width is 1/2. So it'd be 2 times 1/2 minus 1/2 squared plus 1/2. 2 times 1 minus 1 squared plus 1/2. 2 times 3/2 minus 3/2 squared plus 1/2. 2 times 2 minus 2 squared. And I also got 1.25 for that one. So the area is approximately 1.25. It then asks you to use, to do MRAM. So this one, from 0, 1/2, 1, 3/2, and 2, I'm going to use the midpoints. So it's easier for me to think of these in terms of decimals. It may not be for you. Whatever works though. So you're going to use 1/2. So 2 times 0.25 minus 0.25 squared plus 1/2. You're pretty smart people. You're probably catching on to the pattern. 1/2, 2, and then the last one, 7. So when I do that, I get 85 over 64. So the area is approximately 85 over 64, or 1.33. So the next one will be page 275, number 16. So it says the table below shows the velocity of a model train engine along a track for 10 seconds. Estimate the distance traveled using 10 subintervals of length 1 with left endpoint and then right endpoint. So if you look at the table with my intervals are all consistent. They're all 1, so I can go ahead and factor out that if I wanted to. If I'm going to use left endpoint, then I'm going to use all the left sides. So that's the 0, the 12, the 22, the 10, the 5, the 13, the 11, the 6, the 2, and the 6. And so if I do that in my calculator, I get 87 inches. So the distance would be roughly 87 inches. And then if I do B, the right endpoints, again, it's a distance of 1. So I leave off the first 0. But actually the last number is a 0, 2. So it's not going to change anything in terms of my answer. So it's going to be roughly 87 inches also. Okay, 17. So you're walking along the bank, watching the tide carry a bottle. It wants you to estimate how long it travels in an hour using LRAM and RM. One thing you need to be careful of in this table, the time is in minutes and the velocity is in seconds. The easiest way to fix that is to change all the minutes to seconds. So instead of having 0, 5, you're going to have 0, 300, because 5 minutes is 300 seconds. So your step here, instead of being 5 minutes, your width is actually going to be 300. And then you're going to use L, the left, so you'll do 1, 1.2, 1.7, 2, 1.8, 1.6, 1.4, 1.2, 1, 1.8, 1.5, and 1.2. When you type that in, you get that the distance is approximately 5,220 meters. So that would be A. For B, it's basically the same thing, a step of 300, but instead of starting with 1, you start with the 1.2. Then you do the 1.7, and you do all the spaces, and you end with the 0. So when you do that, you should get approximately 4,920 meters. So number 18, you're driving along a dirt road in a car. Your speedometer works, but your odometer is broken. You want to find out how far this stretch of road is. So you're going to go ahead and estimate using an LRAM, an RRAM, and then it says averaging them, which you have to remember is not always the same as midpoint, but you're going to go ahead and average them after you do that. So if we do LRAM, my step here would be 10, and I would start with the 0, the 44, and count up until I hit the 30. When I do that, I get that the distance is roughly equivalent to 3,490, feet. And then if I do an RRAM, my width is still 10, but this time I start with 44, which doesn't actually make a difference because that was 0. And this time I go all the way in the table to the 35, which gives me an estimate of 3,840 feet. And then if I average the two, so I do 3490 plus 3840 and divide by 2, I get 3,665 feet is my average. Alright, we're going to go to page 316 now, and look at number 11. So this one says, the table shows the time to speed data for a 2011 Scarpellone Panther, accelerating from rest to 130 miles per hour. How far had it traveled by the time it reached this speed? It says use trapezoids to estimate the area under the velocity curve, but be careful. The time intervals may vary in length. So there's two things difficult about this problem. First of all, the time intervals are probably going to vary. Second of all, I don't know why they have the speed on the left and the time on the right. That doesn't make a lot of sense to me. But they did. So essentially, in your mind, you need to flip-flop that. So for the first piece, this one's going to be written out kind of long. We went from 3.1 or 1.8 to 3.1, so that's a change of 1.3. So that's kind of like my delta x. It's a trapezoid, so I need a 1/2, and then the sum of my bases. So that's going to be a 30 plus a 40. For the next one, I need a 1/2 again. Yesterday I wrote this at the end. It doesn't matter, but I don't want to confuse you with that. So I went from 3.1 to 4.2. So that's a change of 1.1. And I'm going to use the 40 plus the 50. So then I go from 4.2 to 5.5. So that's a change of 1.3. I'm going to use the 50 to the 60. Sorry about that. And then I went from 5.5 to 7.4. That's a change of 1.9. So I'm going to use the 60 to the 70. And then 9.2 minus 7.4. That's a change of 1.8. So I'm going to use the 70 to the 80. I guess they put the speed change on the left because it was counting by 10, but it doesn't help you to do that really. So it's a change of 2.3. So the 80 to the 90. It's a change of 3.1 from the 90 to the 100. This will make you really happy when you learn the shortcut. So 6.3 from the 100 to the 120. And then finally, from the 120 to the 130. And so it's asking you how far had it traveled. So approximately whatever the heck that is. So type that in your calculator and then check your answer. When I typed that in, I got 1,187.25. What would that be? Miles. Number 12. Ask you to use the table below to, it shows the velocity of a bobsled at 1 second intervals. To approximate the distance the bobsled travels during that 8 second interval. It says to give your final answer in feet, which means it would be easiest to convert the speed in miles per hour to feet per second because the time is in seconds. So if we want to convert something in miles per hour to feet per second, then we have to do a little work here. And I certainly don't anticipate this on my test. I don't really anticipate this on the AP test either. But it's still good practice. So we know there's 1 hour is 60 seconds. And 1 mile is 5,280 feet. And so this right here is our conversion. That's an Algebra 1 thing. And so 5,280 over 60 reduces to 88. So we're going to multiply our speed times 88. So in our new, it wants us to use the trapezoid rule. So 0 times 88 is still 0. 3 times 88 is 264. 7 times 88 is 616. 12 times 88 is 1056. 17 times 88 is 1496. 25 times 88, 2200. 33 times 88, 2904. 41 times 88, 36,608. And then 48 times 88 is 4,224. And my seconds didn't change, so they're still from 0 to 8. So if I'm going to use the trapezoid rule, I do have equal intervals here, so my change is 1. So I can factor out a 1/2 and a 1 if I wanted to. Sorry about that. And go ahead and use the 0 and then the 2 times the middle numbers like we discussed yesterday. So it would be all those middle numbers to 3608, and then add on the 4224. And if you type all that in, you should get your answer. When I did that, I got 14,262, and says give your final answer in feet. Good thing that's already in feet. We're done, finally. Next, we're going to go to page 321. We'll look at number 33. Okay, there's not actually a number 33 on 321. It's on 320, but hopefully you figured that out. So it asks us to do 2 things, to give an upper and a lower estimate. One of those is going to be the left, one of them is going to be the right. So it asks in liters per hour. So my step, since we're going by days, is going to be 24. That's my width. So 24. And then I'll just list for the first one, I'll go for the first, the left sides. And for the second one, I'll go for the right sides. So for the for the left, I would get 4.008 liters. And for the other, I would get 4.392 liters. For part B, it says use the trapezoid rule. So we're going to have a 1/2. My width was 24. So I'm going to use all my numbers this time, and the middle pieces are going to double. I'm sorry, that was not right. That should be 20. My end pieces, or my end values, do not double. So that gives me, I believe, 4.2 liters. 34. Ask you to look at the data from a sled. It monitors its speed, upper, lower, and then trapezoid roll. So same song, different verse. So my step is 3. So if I'm going to do a left, so I would go from 5.3 to 1.11. And then I'll do a right, so I'll go from 5.25 to 0. So 103.05 feet, and then 87.15 feet. Part B asks you to use a trapezoid rule. So you're going to have the 1/2 because it's a trapezoid, the 3 because that's your height. You'll start with 5.3. You'll double the middle pieces. And you'll tack on the end. And when you do that, you get approximately 95.1 feet. Okay, last problem. This is page 32358, A and B. So it gives you a table. And these are actually AP style questions, like from like an AP test. So it says use the trapezoid rule with 6 sub-intervals to approximate. You don't know that notation yet. Don't worry about it. We'll learn it later. Explain the meaning of your answers using correct units. Alright, so we're going to go 6 subdivisions. That's what we have. So trapezoid rule, 1/2. My width is 4, or my height, is 4. So 9.6 plus 2. And you should never do this little ... thing on your actual test. I'm just doing it now because we've been doing a lot of these. So if I type that in, I get 253.2. But it says explain the meaning in terms of water flow using correct units. So that would mean 253.2 gallons of water flowed out of a pipe during the 24-hour period. Part B asks you is there sometime t between 0 and 24 such that the derivative is 0? Justify your answer. This goes back to the last time you had these videos when I was out. So we know that R of 0 is equal to R of 24. Therefore, there must be a time t between 0 and 24 when the derivative of r is equal to 0. By the, remember that was called the mean value theorem. And more specifically, that one, because it's equal to 0, was called Rolle's theorem.